Let's look at part B of question 14. We answered part A and the answer was 46. So now we have to find the maximum number of deliveries that can be made from the manufacturer to the supermarket. And the number of edges represent the maximum number of deliveries that can be made between locations. So what we do is I follow the edges and see what the maximum number of deliveries are that can be made along the edges as I go down from the top edge. Now the first one that I will look at is that one, and the smallest number along that path is 13, and so I write 13 there and I say okay, this has reached maximum capacity. 13 can flow up through this and 13 reaches here. Now I cancel this edge because it's a backward flow and won't consider it. Okay, so this one has reached the maximum capacity. The next edge I look at, you have to come systematically downwards, otherwise it becomes a problem. The next edge I look at is this one, and the smallest value in that particular route that could form a bottleneck is 5. So 5 passes through, another 5 through that, and 5 here. So I'll write 5 here, and 5 gets through here, reaches the end. So that has now reached maximum capacity and will not allow any more deliveries. And so we still see that this is 18, so it still has a capacity of 2 that can be accommodated, and this one has a capacity of 7. So now let us see if there's any other path that can accommodate them. So the next path we look at is which don't have the maximum capacity along their path is this one and that one. Now I can see that 7, okay, more can be accommodated on this particular path, and it is the smallest value along this, but all compared to 19, 11 and 7. So I will allow another 7 to go. Sorry, I think the difference is 13. Oh, sorry, the difference here is 13, not 7. And so 11 is the smallest number. So I will allow 11 to go through, and here another 11 and 11 here. So 11 reaches here. Write that there. Now if you look at it, this has reached maximum capacity. The capacity that can still be accommodated along these edges is 8 over here, and this is 11 plus 5 is 16, so 2 over here. So let's forget about this edge, and we will now look at another edge. So let's now look at this particular route, and the smallest value along those edges is 6. So we accommodate 6 here and another 6 here because we can still accommodate 8 there, and 6 here. So that tells me that 6 can reach here, and we have now a difference of, so it's 6 plus 11 is 17. So we can still have 2 more go through here and another 2 more go through here. But that's really no use because this is a path that has reached maximum capacity. Okay, so let's now look for another path which doesn't involve the edges with maximum capacity. The only one I can see is this one. And along this route from MNR to S, I can see that 2 is the smallest value that can be accommodated here. So I will push through another 2 there, and okay, and add another 2 over here. So, and that is 2 plus 6, 8. So this has reached maximum capacity. And now if you look at it, there's really no way you can go from the source to the sink, because most of the paths have got edges which have got saturated capacities. And if you add all these values, okay, these values that have reached the end, which is also the addition of this, you will get maximum capacity of 37. And you will often find that the position of these edges which reached maximum capacity, a combination of them will help you get the minimum cut, rather than searching for 100 million cuts, which will waste a lot of your time. A combination, like for example, if you look at the position of the edges that reached maximum capacity, they were the ones in yellow. And if you tried, for example, if you were to draw a minimum cut showing the maximum capacity, you could try 13, which is one edge that we got, okay, and that one, and so that's 18. 18 plus 11 is 29. Now you don't have to take 6, okay, you could just take 8, and that would be your minimum cut, maximum capacity. So this method actually helps you not only to calculate maximum capacity, but also identify the position of the minimum cut. Thank you. Now the last question, part C, says, the manufacturer wants to increase the number of deliveries to the supermarket, and this can be achieved by increasing the number of deliveries between one pair of locations. That means along one particular edge. Complete the following sentences by writing the location in the boxes provided. To maximize this increase, the number of deliveries should be increased between which two locations? So in order to do that, you have to look along the edges and see where the differences still lie, where more capacity is possible. Now if you look at this, 13 plus 5 is 18, a capacity of 2, but even if 2 passes through, this will cause it not to reach the other end, okay. Now this one has a difference of 1, and it doesn't matter because LQ would be the bottleneck, and that one can't go through anyway. So that's not an edge, that's not an edge. Now look at the other edges and what we can do. This one is 16 and still has a capacity of 2 that can flow through, but this forms a bottleneck and really no use, okay. Now let's look at MP actually can accommodate another 8, but OP forms a bottleneck, so that's really no use. And now let's look at another edge. This particular MN can accommodate another 7 because 6 plus 2 is 8 and 15 take away 8 is 7. But if you look at 7, can it flow through NP, which can only accommodate another 6? No, but even if 6 can flow through till here, 6 out of the 7 can flow through there, it comes to this bottleneck and therefore it's really not much use. So now let's look at the last edge. So Mn, Nr and Rs. So as we discussed previously, 7 is still possible along Mn and 7 here is possible along Nr, and if we look along Rs, 6 plus 2 is 8 and 8 is possible along Rs. So if we increase any one edge, sorry, this actually has reached maximum capacity, right? So if we were to increase any one edge, it should be Rs because then 7 can flow through, because we still have 7 that can go through Mn and 7 that can go through Nr, and if the capacity of Rs had been increased by at least 7, okay, if it was 15 instead of 8, then that would have been 15, 6 and 2. We could still have accommodated 7 more and this 7 could have gone through. So the capacity of the edge that should be increased is R2S.